What are polynomials? Polynomials are expressions that are separated by plus and minus signs. So if we had a monomial, which just means one term, it may look something like this. Maybe we might have a 3, or maybe x, or even x squared. A binomial, on the other hand, bi means 2, has 2 terms. And so we might have something that looks like x plus 3, or maybe even x squared plus x. I want you to notice that these x's have different degrees. If they were to have the same degree, they would combine and become a monomial, meaning one term. So a polynomial, instead of having just one or two terms, it has many terms. So that means it would have 3 or more. So an example of that might look like this: x squared plus x plus 1. When multiplying polynomials, we have a couple of different methods that we can use. The first method is using distributive property. It involves taking the terms on the outside and passing it out to the terms on the inside. So in this first example, we have 3 times 2x plus 3 times 5. When we simplify, we'll get 3 times 2x is 6x, plus 3 times 5 is 15. And that is our expanded form using distributive property. The next one looks a little bit more complicated, but it's just the same thing done twice. So here we have x plus 6 times 3x minus 1. We'll start off with the x, and we'll pass it out to the 3x and to the minus 1. When we do that, we'll get x times 3x plus x times minus 1. And then we do the same thing with the 6, and we'll pass it out to the 3x and to the minus 1. And as a result, we'll get plus 6 times 3x plus 6 times minus 1. And from here, what we'll want to do is simplify. X times 3x is 3x squared. X times negative 1 is minus x. 6 times 3x is plus 18x. And then 6 times negative 1 is minus 6. So right now we have 4 terms. But since the degrees of the second and third terms are the same, they both have x to the power of 1, they're going to combine. And when they combine, we end up with 3x squared plus 17x minus 6. And there is our polynomial expanded by multiplication. So another method of multiplying polynomials is using the area model. And what we're going to do is take one part of the product and use it as our length, and use the other one as our width. And so if we drew a box, here's our length of 3, and then our width is going to be 2x plus 5. We know that 2x and 5 are different terms because they're separated by that plus sign, so we're going to split it up. So 3 times 2x is 6x, 3 times 5 is 15, and as a result we get 6x plus 15. If we look at our example on the previous slide, we get the same solution. If we were to have something that looked like example 2, it works the same way, because we can take x plus 6 to be our length and 3x minus 1 to be our width. And so x plus 6, here's our length, and here's our width of 3x minus 1. We split it up, and because x plus 6 are 2 different terms, we can split that box in half, and 3x minus 1 are also 2 terms. We're going to split that in half. So now we have 2 terms by 2 terms. So going across, so we're going to go straight across like that. And x times 3x is 3x squared. X times minus 1 is minus x. The next thing is we're going to go straight across for the next term. So 6 times 3x is 18x. 6 times minus 1 is minus 6. And let's take all these terms and put them together. So we're going to have 3x squared minus x plus 18x minus 6. When we combine our like terms, because again, these two x's have the same degree, we'll end up with 3x squared plus 17x minus 16. And again, if we look at our previous slide, it's the same solution, just another way of doing the same thing. So in this problem, we want to solve for x. And since it's put into a product, we can use our zero product property to figure out what x can be so that we'll get 0 for y. So when we look at these two terms, we have x minus 5 and x plus 1. We know that either one or both of them have to be 0 in order for us to get a product of 0. So that means x minus 5 can equal 0 and x plus 1 can equal 0. So these are the two equations that we have. When we isolate the variable by adding 5 to both sides, we'll get x equals 5 as one solution. And then on the other side, if we subtract 1 on both sides, we'll get x alone to get x equals minus 1 as our other solution. So here our solution is x equals 5 or negative 1. So our question says, find the x-intercepts and the vertex of the function. So when we're solving this equation, we need to remember what x-intercept means. It means that if we had a coordinate plane, it's going to be somewhere on this x-axis, and that means y is going to have to be 0. So using this, we can set up our equation and get x minus 4 times x plus 2 equals 0. So now we know that either one or both of these terms have to equal 0. That means x minus 4 equals 0 or x plus 2 equals 0. So when we do this and we add 4 to both sides, we'll get x equals 4 as one solution, and then we'll subtract 2 on the other side to get x equals negative 2 as our other solution. So since these are our two intercepts, our coordinates are going to be 4, 0 and negative 2, 0. I'm going to go ahead and graph this. So here is 4, 0 and negative 2, 0. Now, our very last step is to find that vertex. So if we look at our intercepts, the y's are at the same level, and we know that our parabola has to be symmetrical. When we look at our factored form, we know that it's going to be a positive parabola, so it's going to be smiling at us. And so our vertex will be somewhere around here. And because we know that symmetry exists, it's going to be in the middle of these two coordinates. So if we want to find the x value, we're going to have to find the average of our two x coordinates. So if I want to find the point between, I can add those two up. So 4 plus negative 2, and then divide it by 2 to find that middle point. So that gives me 4 plus negative 2 is 2, divided by 2 is 1. So that means that my x-coordinate is going to be 1. And that's reasonable because if this were 1, negative 2 is 3 away, and 4 is also 3 away. Alright, now that we have that x, we can plug it back in, and figure out what our y has to be. So y equals 1 minus 4 times 1 plus 2. Y equals negative 3 times 3, and that means y is equal to negative 9. As a result, our vertex will be 1, negative 9. So far, we've learned how to find x when we have factored form, but that's not always going to be the case. Sometimes we're actually going to need to factor first in order for us to be able to do what we've learned how to do so far. So one way of doing that is by using the x box method. So first off, the way the x works is we set it up like so. So here's our x. The value on top is always going to be a times c, and the one at the bottom is b. The two numbers on the side will multiply to be a times c, and it's going to add up to become b. So let's go ahead and try this with the equation that we have over here. Over here we have 5x squared, so that means that this has to be a, minus 9x, so this is b, minus 2, and that's our c. So a times c is 5 times negative 2, that's negative 10. So if we were to set up our x box, we know that there's that negative 10, and then our b is pretty easy to spot because it's right there. There's negative 9 for my b. Now I need two numbers that multiply to be negative 10 and add up to be negative 9. I know that 1 times 10 is 10, and I know that if I want a negative 10, one of these has to be negative. So if I make it a negative 1, if I add it together, I'll get positive 9. But if I make this a negative 10, I can do 1 plus negative 10 equals negative 9. So that means that these are the numbers that I want. I want 1 and negative 10. Here's 1 and negative 10. So that's the first part. I've got my x. Now let's do my box. Here's my box. I know that my box is pretty easy to set up because it's going to be everything that my standard form is worth. So here's my 5x squared, and the negative 2 goes here. Instead of putting in negative 9x, I was able to split it up into 1 and negative 10. So here's going to be 1x, and there's negative 10x. The next step on getting what I want on the outside is by finding the GCF. The GCF is my greatest common factor, and that means what do my two terms have in common that's being multiplied. So I'm going to go ahead and start off on my horizontal. When I look at 5x squared and negative 10x, I see that there's a 5x in common. Because 5x times x is 5x squared, 5x times negative 2 is negative 10x squared. When I look at my x and my negative 2, they don't really have anything in common, so that means that they have to share a positive 1. Now I'm going to look at my verticals. When I look at my 5x squared and my 1x, I see that they have x in common because 1 and 5 only have 1 in common. And then when I look at my negative 10 and negative 2, I see that there's that negative in common. And the common factor of 2 and 10 is 2. So from there, I get my two factors. That means I have 5x plus 1 as one factor, and then I get x minus 2 as my other factor. And now we're back to what we had before, and we want to find what x is when y is 0. So again, we got to split this up because either one or both of them have to be 0. That means that 5x plus 1 equals 0, or x minus 2 equals 0. And here we're just going to isolate for x. So let's do the harder one first. Let's subtract 1 on both sides. We get 5x is equal to negative 1. Divide 5 on both sides, and x is equal to negative 1/5. That's one solution. And on the other side, just add 2 to both sides, and x is already alone for us. So x is equal to 2. And there we have it. We started from standard form, changed it to factored form, and ended up with our solution here. Instead of using the Xbox method to factor, we can use the x and then rewrite our equation and regroup. This is how we might do this. So we're going to start off with our x, and it's going to look exactly like it did in the previous question because we are using the same equation. So we had decided before that this is 1 and this is negative 10. This actually tells us how to break up our negative 9x term, just like in that box. So when we rewrite, we'll get 5x squared plus 1x minus 10x minus 2 is equal to 0. And from here, what we're going to do is regroup by factoring it out separately. So we're going to take these terms and factor it out. So 5x squared and 1x has x in common. So I'm going to take out the x and leave the 5x and the 1. For the next one, I have negative 10 and negative 2. That has the negative 2 in common, so I'm going to take that out. Negative 2 times 5x is negative 10x, and negative 2 times positive 1 would work. Here I want you to notice that these two terms right here are the same. That means we can take it and factor it out and group it together as 5x plus 1. And then take the other 2 bit and put it together, x minus 2. As a result, this is our factored form. And if you noticed, it's the exact same factors that we had when we were doing Xbox. And again, we would do the same thing and say x minus 2 is equal to 0, and 5x plus 1 is equal to 0. Here we have x equals 2, and x equals negative 1/5, just like in our other slide. So this is another way of splitting it up without using that box. So now we have an example that is in factored form. But if we wanted to factor it completely, we need to be careful for greatest common factors. If we look at our second term, the 7x minus 7 has a 7 in common. So that can be distributed back out to form 7 times x minus 1. When we take our original equation and rewrite it, we'll end up with 7 times x plus 6 times x minus 1. And this is what it looks like when we factor something out completely.